this, what to do. I think it is very good for you to be very consistent in how you do these. Okay, I mean, and again, this is the same thing I do when I do these questions, all right, just so that I can have everything that I need here. So this says the radius of a cylinder is decreasing at a constant rate of 5 feet per second. All right, so radius decreasing at a constant rate of 5 feet per second. Then I have the volume remains constant at 36 pi cubic feet. At the instant when the height is 25 feet, what is the rate of change of the height? Okay, and then it reminds you that the volume of the cylinder can be found with this. So if I haven't already said this, which I think I said something similar to this, but on the AP exam, there is no formula chart. I mean, even on the SAT test, there's a little bit of a formula chart, right? But you don't really need it. Don't look at me like that. You'll be fine. You have to know basic things like some area formulas, which at this point you should know. But for volume, they give you these formulas. So if you need a formula, even if there's no formula chart, things like volume of a cone or volume of a cylinder, that'll just be in the question like it is here. Okay, so it's not like you have to know every formula you've ever seen, but there's not like a separate formula chart type of thing. All right, so the first thing I always write down is what I'm looking for. And this asks me, it says, what is the rate of change of the height? So the rate of change of the height is going to be dH dt. That's equal to, I'm going to put a question mark because I don't know, because it's what I'm looking for. But then I can come up with the units, okay? So what are the units for height in this question? Feet. And what are the units for time? Second. So it's feet per second. That's how I come up with that, right? And then I'm also going to write down, okay, do I know the height for this question? And it does say at the instant when the height of the cylinder is 25 feet. So I've got that to fill in, 25 feet. So then I go back through. I've already read through the question for once and kind of underlined some stuff, but go back and write down what else we know. So it says the radius of the cylinder is decreasing at a constant rate of 5 feet per second. So the dr dt is equal to, what is dr dt? -5, good. And that would also be feet per second. And then, do I know the radius for this particular question? No, not something that they gave me. Doesn't mean I can't find it, but not something I know right this second. But I do know that it'll be feet. If I go find it, I can go back and fill it in. So then I have to figure out what else I have. So radius, then it says the volume remains constant at 36 pi cubic feet. So that means that my volume is 36 pi cubic feet. So then they gave me that, so that means I also need to have something for dV dt. So what is dV dt here? 0. Why? Because it's constant. If it remains constant, so like the height is changing, but it's telling me at this instant is what we're looking for dH dt. But so for this question, it is 25. Volume is always 36 pi. So the rate at which it's changing is 0 feet cubed per second. And then can make sure that I'm kind of not missing anything that would make sense for this question, because I have this formula right here of volume. And so I have volume, radius, and height. And I have all three of those things taken care of here. We all good on all that so far? All right, so in order for me to get these rates, I need to take the derivative of the volume. So my volume formula, which is pi r squared h, I'm going to take the derivative with respect to time, right, of this here. So that means that'll give me dV dt is equal to, all right, pi is a constant, right? So it's just treat it like a number. And I'm going to stick it to the r squared, just keep those two things stuck together. So what rule do I need to do when I'm doing my derivative? Product rule. So I take the derivative of the first, which is going to be 2 pi r what? What do I have to have here? dr dt times the second, which is h, plus the first, which is pi r squared, times the derivative of the second, which is just dH dt. Okay? Any questions about anything at this point? Bless you. We all good? All right, so now I'm going to substitute in everything I can. So dv dt is 0. That's equal to 2 pi. Do I know what the radius is? I do not. And that's not what they actually asked me for. So I should probably be able to plug it in. Do I have enough information to find the radius? Yes, I actually do. So I'm going to pause here for a second, and I'm going to come over here in the very little room that I have, and I'm going to substitute everything I can into this formula so I can find my radius. I have the volume. This is 36 pi. That's going to be equal to pi times r squared, and I don't know what r is, times h right now, which is 25. Everybody with me? So now I want to get r squared by itself. I'm going to divide both sides by 25 pi. The pi's will cancel out. That will leave me with 36 over 25. That's equal to r squared. So what is r? 6 over 5. Officially, it's plus or minus 6 over 5, right? But would a negative radius make sense? No. So just don't forget that it's plus or minus. So 6/5. So see, I still have that blank there, but now everything is filled in except for what I'm actually looking for. So now I can come back over here. So then I'm going to multiply this by 6 over 5. And then, do we know dr dt? Yes, what is it? -5 plus pi times. Now, here's another little trick of the trade here. I can substitute in r, but do I actually know what r squared is? R squared is 36 over 25, right? So you have, oh, what did I do wrong? Oh, the 8th. Oh, dang it. Thank you. Times, yes, I left out the height. Thank you. I have that. I have that. Height is 25. Okay, now plus pi times, and I can put in 6/5 and square it, or I can just straight up substitute that in. Whatever, it doesn't matter either way. Does it make sense why I could do either one? Okay, so then this is 36 over 25, and then dH dt is what I'm actually looking for. All right, everybody okay with that? Now, we have to simplify things down some, or we have to solve for dH dt. We can simplify things down. If in doing that, is there room for lots of error in simple math? There is, right? Your only goal here is to find dH dt. I just need to get this thing by itself. Remember, I don't have to multiply all this stuff out. I can, if you feel like it's safer for you, I mean, because clearly I can kind of cancel the 5s out and I can do some things, but you don't have to. Have you ever made mistakes in doing those things? Absolutely. I can't even put the height in the formula, right? So what you can do is this, right? Because we have the safe stop things that we can do, right? I have this is all one big term right here. And then this is the term that has dH dt in it. I'm going to take this whole thing and subtract it to the other side. Does that make sense? So I'm going to get -2 pi times 6/5 times -5 times 25. Right? And that's equal to pi times 36 over 25, or 6/5 quantity squared is fine too, dH dt. Right? Then what do I do to get dH dt by itself? Divide. So then I can say dH dt is equal to, got this big old fraction, -2 pi times 6/5 times a -5 times 25 all over pi times 36 over 25 Now, I have fractions and fractions. I got all, it absolutely does not matter at all. I've got dH/dt by itself. That is a safe stop. Let's not do anything else, okay? We can stop, but we need units. What are our units? Feet per second. If it just bothers the heck out of you, if it bothers the heck out of you and you feel like you need to simplify this stuff, that's fine. But if you do anything wrong, then you're not going to get credit for your final answer. Okay? You just leave it, which is counterintuitive to what most of us made you do. Questions? Any question? Ask me a question. Where did I lose you? I lost you somewhere, I can tell. That's when I stopped to do, that's when I stopped to find the radius when I was substituting it in. Okay. You good? Ask me a question. You have a question? Yeah, absolutely. We write down what we're looking for, what we know, make sure we have everything laid out. My suggestion is make sure you have everything laid out, kind of like what I have in purple over here, before you even start to take a derivative or do anything else, okay? And some of you had the cylinder drawn, which is fine, and that is one of those suggestions, is to draw it. One of the reasons I did not here today was because I knew I didn't have that much room. I know I keep complaining about these new boards, but I can't write like I did on the other ones. I printed out my notes from last year, and the handwriting, it's just so beautiful, and it all fits there, and I just can't with these. I have to write bigger, and I knew I wasn't going to have enough room. But we all good? Questions? Anything else? All right, so let's look at the next one. Now, the next one I definitely am going to draw the picture because I think it's going to help us wrap our mind around things. All right, so we have the volume of a cube is decreasing. So volume is decreasing at a constant rate of 475 cubic feet per minute. At the instant when the side length of the cube is 5 feet, what is the rate of change of the surface area of the cube? Okay, so lots of words, right? So let's go ahead and start with what we are looking for. Now, one thing we need to know about a cube, and I am going to just go ahead and draw it because I know that we are going to need it drawn, and I'm not going to worry about it looking too beautiful, and it's not an art class, but if you're trying to draw a prism or a cube, I just kind of have 2 offset squares there. One of them doesn't even really look squarish, but it's good enough. And then you can just connect it like that. It's good enough for what we need. Okay. So we're talking about surface area, volume. So we know volume is V. Surface area, you can use SA for surface area, but then 2 letters makes things confusing. So surface area, we really use a capital S for surface area and a lowercase s for side length. Okay, so I will try and make them real obvious when they're lowercase or capital in here. But so this would be like, this is a side length, and this is a side length. Those are little s's. Okay. We are going to need, so when I do this over here, what am I looking for? It says, what is the rate of change of the surface area? So ds, big S, dt is what I'm looking for, right? So then when I try to figure out my units, so in this particular question, what are the units for time? Minutes. Okay, so we can go ahead and get that in. And then we are using feet, but for surface area, it would be feet what? Squared, because it's area. Okay, feet squared. Oh my goodness. Yes. Thank you very much. Okay. For you. All right. So then surface area is something that I'm going to be interested in. They didn't tell me what it is, so I may or may not have to find it. Probably going to have to find it. And what would the units be on surface area? Feet squared. Okay. All right, so that's what I need. I like to have that first. Okay, then I'm going to go back, and it says the volume of a cube is decreasing at a constant rate. So this gives me dV dt. Okay, dV dt is what? Negative 475. And what are the units going to look like that on? Yeah, feet cubed per minute. And then volume, did they give me the volume of the cube? No, they did not. But whenever I figure it out, if I need it, that's going to be feet cubed. Okay? So then it says, at the instant, when the side length of the cube, little s, is 5 feet, so little s is equal to 5 feet. So that means I also need d little s dt. I don't know what it is, right? And that's going to be just feet per minute. Okay. Everybody okay with how we found all of that stuff and how I got all that? So I've got the surface area, the volume, and a side length. And for surface area and a volume of a cube, the only thing we need is the side length, because the height is the side length, because they're all the same, right? So when I come back over here, look at this. So this could be S also. Those are not 5s, they are S's, even though S is 5. When I want to find, so what I don't have in here, volume is just length times width times height, right? S times S times S. And so S is actually equal to 5. So what's 5 times 5 times 5? 125. So I can put a 125 in here. Maybe I need that, maybe I don't, but I can find it, right? Surface area, well, the area of one of the squares is S squared, or in this particular case, 25. How many squares do I have? 6. 6 times 25. You have 6 quarters. How much money you got? 150. Okay. Think in terms of quarters. If you can think in terms of money, you're good. So now the only, so I know that this is an unknown. It's what I actually want to find. And then, but I don't know what this is. Maybe it matters, maybe it doesn't. But I have, let's see. I need the actual formulas for surface area and volume. So for my surface area, pretty much just did it. It's S times S. S squared is 1 square. And I have how many? 6. So it's 6S squared. For volume, what's my volume going to look like? S what? Cubed. So now I'm going to look at this and say, okay, bless you. I'm dealing with surface area and volume. The part that I'm going to want to use first, where I actually have some information here, is I have this. So I think I want to use this and the side length. Like I have some information here, and that can help me find that, which is not exactly what I'm looking for, but I've got to get to that point. So I'm going to take the derivative of the volume. So when I do this, and this is going to be d dt, this is going to give me dv dt is equal to 3s squared, then what? ds dt. Now, if you're thinking, I'm not sure I would have known to start with that one, I might have started with surface area because that's the one that they're asking me for. Let's go ahead and take that derivative, and then I'll show you how if you go down the road that's not best to do first, how you'll know that you're actually stuck. So let's go ahead and take this derivative also, because we're going to have to do that anyway. So I'm going to take the derivative of this with respect to time. So this is going to give me ds, big S, dt, which is equal to 12s d little s dt. Okay, you agree with that? So let's say you were thinking, well, I think I'm supposed to start with surface area first. Well, when you take the derivative and then you go to start substituting things in, you're looking for ds dt, so you don't know what that is. You know what s is, it's 5, but you also don't know what this is. And the only way you can find that is to go through volume. Does that make sense to you? So when we go over here and I have dv dt, I know what that is. I know what s is, so my only unknown here would be this one right here. Okay, so we're going to start here. dv dt is negative 475. That's equal to 3 times 5 squared ds dt. Now, unlike the question we just did before, where, I mean, if I'm just looking for ds dt, I can do negative 475 over 3 times 5 squared and be done with it. But I think I actually want a real number because I'm going to have to go farther, right? This isn't a time you'd want to use the safe stop. So this is 3 times 5 squared. 5 squared is 25 times 3 is 75. So negative 475 equals 75 ds dt. So then ds dt, little s, is equal to negative 475 over 75. Now, even though I simplified it some, do I have to simplify it more? I don't have to. And maybe in the end, I might decide I want to. If I decide I want to or it's important, then I can then, or you can do it now. But if you reduce the fraction wrong, then you're toast, right? So I think I'm just going to leave it like this. And the downside of leaving things sometimes is because they get a little freaky looking like this. But that's, again, just you have to decide what's best for you. So now that we have that, let's go back over here. And what we're actually looking for, and I guess I can write that in here, negative 475 over 75. So that gave me this. Now I'm going to use this and this to help me find what I'm actually looking for. All right. So ds dt, big S, dt is equal to 12 times what? 5 times negative 475 over 75. Are we capable of simplifying that? Do we have to? No. So do we want to? No. What are we missing from our answer? Units. And so I would probably, just so somebody could find my stuff, I would probably rewrite it. ds dt is equal to 12 times 5 times negative 475 over 75. And then what are my units? Feet squared per minute. Okay. And honestly, it wouldn't have been that terrible if these numbers weren't semi-decent. If I still had 3 times 5 squared there and I had it there and there, I would still be correct. Okay? You absolutely do not want to risk losing a point because you divided or multiplied wrong. Okay? Should we be capable of simplifying that? Absolutely. Are there times where you were going to need to do that? Absolutely. If this was a multiple choice question, this would not be an answer choice. If this was a multiple choice question, I highly doubt, I can't guarantee it, but I highly doubt the answer choices would look like that. Like you'd have to be able to simplify, okay? So having those skills are still important. You just kind of don't want to risk that. Because this isn't testing can you multiply. This is testing do you understand related rates, okay? Yes, you do. You understand more than you think you do. How are we doing with that? We good? Okay. So do y'all have another, I don't know which side of the paper we're on. You have another side, right? You flip it over. Same thing on the other side? And that was part 2? Okay. So then here is, wait. You don't have that? Did we do this part? The pebble one? Yeah. Oh, I copied these wrong. Oh, goodness gracious. No wonder. I'm like, what the heck? Okay. Pause. So I'm going to read through this. I'm going to show you what I would do here. And again, consistency is the key. So we have a cylindrical barrel. They drew a picture for me. That was very, very nice. A diameter of 2 feet. Okay. So in this question, we're using volume. Do we actually use the diameter? No. So I'm going to write for myself here. This means that R equals 1 foot as I go. Almost always when you're given a diameter, it's usually the radius that you're using in the formulas. Contains collected rainwater, as shown in the figure below. The water drains out through a valve, not shown, at the bottom of the barrel. The rate of change of the height is this right here. So they give me that. H is measured in feet, T is in seconds. The volume V of blah, blah, blah. So it gives me the formula. That's really nice. Now we want to determine the rate of change of the volume of the water with respect to time when the height is 4 feet. Okay, so what I'm looking for, that's the first thing I always write down. I'm looking for dV dt. I don't know what it is. That's what I'm looking for. I put my units on here. Units for volume, feet cubed per seconds. And then, did they give me the volume? No. And I may or may not need, I can figure it out. But you know what? I don't even know that I want to figure it out. I'm only going to figure it out if I decide, you know what, I think I have to figure it out. Because on the cube one that we did we actually need these things? That's one reason why I did it. Did we actually use these two numbers? We didn't, right? So we didn't need them, but you don't always know at the beginning, so it's good to have the blanks there. But I didn't have to find them first. I did that kind of to talk you through a cube, but also to show you we did extra work. So I think even though, yes, I can find the volume, I'm going to wait because maybe I don't need it, right? Maybe I do, maybe I don't. Well, we'll see what happens. So then I'm going to go back and start reading through everything else. I know with volume that I'm going to have to take care of a volume, a radius, and a height. That's how I know I'm going to need 3 rates and 3 other things. So it tells me that this is a barrel and the radius is 1 foot. Is that going to change? No. So at this instant, my R is equal to 1 foot, and it's just plain old feet for 2 reasons I know that. First of all, that was labeled and it already told me that. Plus, the radius is something you can measure with a ruler. It's not going to be squared or cubed. So then dr dt, they didn't straight up give it to me, but what is it? 0, because it's not changing. So the rate of change is 0 if we're not changing, and this is feet per second. Everybody with me on that? And then the other thing I have, so I keep reading blah, 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 and then it tells me that dh dt, and this time it's an equation. It's not just a number like other things that we have, but that's okay. dh dt is equal to negative 1/10 times the square root of h, and that would be feet per second, right? So then when it told me I want to determine the rate of change when the height of the water is 4 feet. So h is equal to 4 feet. So once I've got all of that, and again, not necessarily all of it filled in, but all of it written down, filled in with what they gave me, then I am ready to move forward a little bit, okay? And so I have volume. I'm going to need to take the derivative. So my volume formula, pi r squared h. So if you haven't done so already, go ahead and do the derivative. Okay? Actually, we've got like 2 minutes left. So here's what I want you to do before tomorrow. Do this derivative on your own. You can double check yourself because I think we also did the same derivative on the other page, but don't just copy it down, do it yourself. Then go through and see if you can finish this question, and we will start here with questions tomorrow. Does that sound good? You can do that? All right, perfect.